Hi, this experiment has been performed as part of computational experiment in electromagnetics lab IIT Delhi. It deals with studying the wave scattering phenomena for various obstacle sizes. Diffraction or wave scattering is the process by which a system of waves is spread on passing through narrow aperture or across an edge, thus resulting in interference between the waveforms produced. Wave scattering finds its applications in everyday observations such as the sky appears blue during the day as the shorter wavelength, that is, the blue end of the spectrum, is scattered by the particles. Rainbow pattern can be seen on a CD or DVD because the closely spaced tracks on a CD or a DVD act as a diffraction grating. The person here can hear radio in spite of the presence of an obstacle because the sound waves diffract around the corner edge. This degree of bending depends on the relative size of obstacle to wavelength. In this experiment, we study the significance of this ratio using a very popular numerical technique in electromagnetics, namely the finite difference time domain or the FDTD method, as it discretizes the time-dependent Maxwell's equations in partial differential mode to space and time domain partial derivatives using the central difference approximations. This is the schematic for our simulations. We set the block size to 32 cross 32 units, which is the size of the computational domain throughout the experiment. Obstacle width is 0.5, which remains constant while we vary the length from 0.2 up to 10 to identify the different wave scattering regimes. The source is placed at -7,0 while the obstacle in all the three cases at 2,0. Finally, we have a PML layer of 1 wavelength thickness to avoid the necessary reflections from the border as it absorbs all the waves and thus gives results similar to the infinite computational domain. A list of parameters used in the experiment. We set the source frequency to 1, which means that the wavelength is equal to the speed of the source. Resolution is set to 20, which implies that a domain is specially discretized into 20 units along each dimension. We will now study the three different regimes of wave scattering. Case 1. When the obstacle size is 0.2, which is much less than the wavelength, we see that the wave travels almost undisturbed as the obstacle is too small to affect the wave propagation. Case 2. When the obstacle size is 1, which is approximately equal to the wavelength. Here we see a small shadow region on the right of the obstacle, but still significant diffraction takes place. We also see little interference between the incident and the reflected waves on the left hand side. Case 3. When the obstacle size is 10, which is much greater than the wavelength. Here we observe a complete shadow region on the right of the obstacle, that is, there is no diffraction and we see a interference pattern of reflected and the incident waves on the left, also known as the linear propagation. Here is the MEP code used to produce our simulations. We ran 200 iterations of our code as it was enough to produce a steady state solution. We changed the length of the obstacle as per our requirement for the three cases. Thanks for watching the video.